Millions of years ago, during the formation of our planet Earth, the Indian subcontinent was not part of the Asia continent. Movement of Earth's tectonic plates caused the tectonic plate carrying the Indian subcontinent to collide with the Asian continental plate to form the Himalayas. This resulted in the Indian subcontinent with various geographic locations of low-lying coastlines, forests, plateaus and mountains. Due to its location, the Indian subcontinent is also subject to varying weather conditions from sunny dry summers, wet monsoons, cold foggy air and snow in some locations. The atmospheric airflow movement over it, combined with interaction with the surrounding seas, leads to variations in tropical temperatures, circulation and rainfall. The erstwhile Mysore state in the Indian subcontinent was also under the sea several million years ago. This fact was proved through the research and field work by noted geologist late Dr. C.S. Pichamuthu, who headed the Department of Mines and Geology of Mysore state and was also president of the Geological Society of India. Late Dr. C.S. Pichamuthu was also the author of several geology books, among which included The Physical Geography of India. But that is another story. This is the story of Dr. C.S. Pichamuthu's youngest son, the Indian scientist Dr. J.P. Pichamuthu, and his indigenous invention Automatic Visual Range Assessor or AVRA, a vital aid in ensuring the safety of millions of air travelers in India, reduction of unnecessary fuel consumption and saves time. The year was 1942, the year the Quit India movement started. In September 1942, a body called the Council of Scientific and Industrial Research, CSIR, came into being. Late Bahadur Sir Arcot Ramsamy Mudaliar, who was to become the last Diwan of Mysore state, was instrumental in its formation along with late Sir Shanti Swarup Bhatnagar. Earlier the same year, in January of 1942, Dr. J.P. Pichamuthu, who is the youngest son of late Dr. C.S. Pichamuthu, was born in Mysore. Two events separated by a few calendar months in the year of Quit India movement, on an Indian state that had risen above the ocean waves. The events, apparently unrelated and unconnected but together, were to have a significant, positive impact on the safety of millions of air travelers in India in the years to come. An earth-shaking sequence of events indeed. Dr. J.P. Pichamuthu, along with his siblings, his mother and with his father, Dr. C.S. Pichamuthu, who was working for Mysore state, moved to Bangalore, where his grandfather Mr. S.V. Pichamuthu was the first Indian headmaster of Wesleyan Mission School. Dr. J.P. Pichamuthu started his schooling in Bangalore at St. Anthony's Boys' School, where he got a double promotion, and Bishop Cotton's Boys' School in Bangalore. His father, Dr. C.S. Pichamuthu, and his mother Mrs. Ada Pichamuthu, along with Dr. J.P. Pichamuthu, their youngest son, moved to Singapore, where Dr. C.S. Pichamuthu was invited to set up the Department of Geology in the University of Malaya, which at that point in time included Singapore. So, Dr. J.P. Pichamuthu continued schooling at Anglo-Chinese School, Singapore, where, apart from educational knowledge, he picked up life skills in the Boy Scout troop along with lessons in the hockey team which he was part of. He secured the first rank in South India at the IIT Joint Entrance Examination and secured a Bachelor of Technology degree in Electrical Engineering at Indian Institute of Technology, Kharagpur, IITK. He then did his Masters in Electrical and Electronics Engineering at University of Illinois, Urbana-Champaign, USA, followed by a Ph.D. in Laser Physics. After a short stint in Bradley University, USA, he chose to return to Bangalore from USA in the early 1970s with the goal of using science and technology for the benefit and growth of India. He joined National Aeronautical Laboratories, Bangalore, which was part of CSIR, under the directorship of late Dr. S.R. Valluri. Dr. J.P. Pichamuthu commenced research on problems related to optics in NAL. Within a short period of time, he successfully converted his research in the lab into a completely indigenous industry product. This is largely due to his resourcefulness combined with superior knowledge and skills in optics and electronics. Having been a scout and the captain of several hockey and cricket teams, he successfully built, grew, managed and led over the years his project team comprising of individuals from different backgrounds with different skills, ambitions and temperaments. He was assisted by the team he led comprising of engineers and scientists, Dr. H. Leelavati, who worked on the software, late Dr. Veeraraghavelu, Mr. Nilakantan, who worked on the electronics, Mr. T. Ramakrishna, who worked on the design of the body and mechanical components, in the 1980s onwards. They were joined later in the 1990s by late Mr. Srinivas, Mr. Kanakkamudhu, Mrs. Gayatri, Mr. Santosh among others. Dr. J.P. Pichamuthu, a hockey and cricket player, acknowledges the role his team played too in its success. All the electronic components, housing and software were developed in-house at CSIR, NAL. The product he and his team developed was called AVRA. The acronym AVRA stands for Automatic Visual Range Assessor. AVRA from the 1980s onwards automatically calculates and provides information at the required time on the distance from which the runway lights and markings would be visible to the pilot in a straight line when he descends to land. India is a land with several different weather conditions ranging from dust storms, monsoon rains, fog, smog, and snow. Pilots also encounter ground-level fog and haze affecting visibility. For flights using CAT instrument landing system operation during low visibility conditions, it is mandatory to provide the runway visual range or RVR, which is the exact visibility at various runway ends to ATC or pilots for safe landing/takeoff in multi-runway airports in India. RVR is the deciding factor on whether the runway operating conditions are CAT 1 or CAT 2 or CAT 3. This would decide the usage of instruments or not for landing. It may be noted that the orientation of the runways has been designed in such a way that it is climatologically best for the direction of the winds at the location. This is, as aircraft landing or takeoff takes place mostly against the winds. Therefore, a more accurate value of RVR is necessary according to International Civil Aviation Organization rules, which is defined as the range over which the pilot of an aircraft on the central line of a runway can see the runway surface markings or the lights delineating the runway or identifying its central line. AVRA is in technical terms a transmissometer. This uses an optical detector, which is the electronic equivalent of a human eye, to measure from a distance the light intensity and brightness visible from a lamp, similar to a runway light in the existing weather anytime. This technology was an indigenous development of the scientist and his team. This reading along the runway of the light intensity and brightness is taken at fixed distances known as baselines from the lamp, which is part of the AVRA. AVRA then calculates the distance and two values known as RVR, runway visual range, and MOR as per international aviation standards. The information is then transmitted to the ATC, who provides the input to the pilot. The pilot and ATC can then decide whether the conditions are suitable for him to come in to land when still a distance away in the air. A simple demonstration of the concept can be done by placing a coin in a container of water. The symbols and embossed features on the coin will be clearly visible from above. When some amount of soap or shampoo solution is added to the water, the visibility of the coin at the base of the container is reduced. The water in the container can be likened to the denser layer of air above the runway and the soap solution, fog or any particles or aerosols in the air that affect visibility. In 1984, at the time of Indira Gandhi's assassination, his son Sunil remembers that Dr. J.P. Pichamuthu was stranded at Madras airport where he and his team were working on extensive field trials of the product at the runway. Dr. J.P. Pichamuthu and his team were provided food and drink brought by an airport security guard from his home. Years later too, due to his work at Delhi, he was unable to attend his son's 10th standard graduation ceremony. His wife, Mrs. Sudha Pichamuthu, a maths and physics teacher, had set aside her career to rear their two children Sunil and Priya and manage their home. The successful trial of the Avra at Minambakam Airport, then Madras, Chennai, where it outshone its competitors both on accuracy and cost while meeting stringent air safety requirements, was done in 1986. The inventor and his team won the National Research Development Corporation Invention Award in 1987, and a patent for the indigenous technology developed and used. Avra successfully held its own against foreign competitors in the growing Indian market. The safety of Indian air passengers with a growing number of airports under Udan is of highest importance. It continues to maintain an edge over foreign competitors through the years in terms of accuracy and cost. Mr. Bhadareshwar Tanti, a Lok Sabha MP in the 1980s, during the question-answer session of the Indian Parliament's 8th Lok Sabha in the year 1988, inquired on the achievements of the CSIR. The Automatic Visual Range Assessor or AVRAR was listed as one of the top 10 inventions of CSIR in India under the 7th Five-Year Plan by late Mr. K.R. Narayanan, who was the then Minister of State for Science and Technology and later on President of India. Following that, one of the objectives for Indian civil aviation in the subsequent 8th Five-Year Plan was to reduce turnaround time in airports. This is an indicator of the significant impact that AVRA had on Indian. The visual range is a parameter of central importance in flight operations, which determine whether a pilot may land or take off. The largest number of fatalities in an Indian Airlines plane crash was on the 19th of October 1988 at Ahmedabad in the Indian state of Gujarat. There was no instrument at the airport to measure the crucial factor of AVR. Indian Airlines Flight 113 crashed at Ahmedabad on the 19th of October 1988 at approximately 7 a.m. IST, killing 127 passengers and 6 crew members. This was due to the pilot inability to see the runway and no information of the AVR available at hand. In a recent plane crash, which involved Air India Express Flight IX-1344 on the 7th of August 2020, in a second attempt at landing on the tabletop runway of Kozhikode Airport, again no instrumented reading of AVR was provided, but only a manual estimate of runway visual range (AVR) was given, and, as per the crash investigation report, the windshield wiper on the plane also was non-operational during landing in heavy monsoon rains at night. This, along with the uncertainty in exact AVR, would have affected the pilot's ability to sight the runway while approaching it.
Vision is a pilot's most important sense to obtain reference information during flight. The eyes send pictures to the brain about the aircraft's position, velocity, and attitude relative to the ground. Here is how the eye works. Light from an object enters the eye through the cornea, and then continues through the pupil. The dilation or constriction of the pupil is controlled by the iris, which is the colored part of the eye. The pupil's function is similar to that of the aperture of a photographic camera. It controls the amount of light that enters the eye. The lens is located behind the pupil, and its function is to focus light on the surface of the retina. The retina is the inner layer of the eyeball that contains photosensitive cells called rods and cones. The retina's function is to record an image similar to that of the film in a camera. The macula in the center of the retina have cones that are more densely distributed. In the center of the macula, there is a tiny depressed spot called the fovea centralis, which contains only cones and is the area with the sharpest vision. The rods are mainly located in the periphery of the retina, an area that is about 10,000 times more sensitive to light than the fovea. Rods are used for low light conditions or night vision. They are involved with our peripheral vision to detect position references, including objects, both fixed and moving, in shades of gray. They cannot be used to detect detail or to perceive color. Light stimulates cones and rods, which in turn initiate nervous impulses that are carried to the brain via the optic nerve. Dark adaptation is the process by which the eyes adapt for optimal night visual acuity under conditions of low ambient illumination. The eyes require about 30 to 40 minutes to fully adapt to minimal lighting conditions. The lower the starting level of illumination, the more rapidly complete dark adaptation is achieved. To minimize the time necessary to achieve complete dark adaptation and to maintain it, you should avoid inhaling carbon monoxide from tobacco smoking or exhaust fumes. Adjust instrument and cockpit lighting to the lowest level possible. Avoid prolonged exposure to bright lights. Use supplemental oxygen when flying at night above 5,000 feet MSL. If dark adapted eyes are exposed to a bright light source, like searchlights, landing lights, flares, or laser lights, for a period in excess of 1 second, night vision is temporarily impaired.
Captain Amit Singh, a noted aviation safety expert and pilot, describes the same.
And the most important thing, you have to see the runway where you're landing. In order to see the runway, there are many ways. We have instrument approaches, which are high precision. We can have non-precision approach or visual approach. Irrespective of what kind of approach you're doing, ultimately you have to see the runway. And what determines the actual visibility is, or the prevailing visibility, the accuracy of the visibility reported is the determining factor. As the visibility keeps on deteriorating or decreasing due to various factors like environmental haze or pollution, or a combination of two, or be it weather, rain, all these can come in combination of various combinations actually, and can at times be hazardous to safe aviation or the operation of aircraft safely. So a pilot basically needs an accurate assessment of the prevailing conditions on ground, while the pilot is about 100, 150 or 200 kilometers away from the airfield. So that is how they determine if the visibility is very close to the minimum required, then they have an alternate planned, or they may have two alternates planned if the visibility is below. So there are different criteria, but ultimately it is the visibility or the prevailing visibility at the airport which determines the operation of the flight, continuation of the flight, and the termination of the flight. This prevailing visibility can be reported in two ways: by a human observer or electronically. Human observer is the traditional way, but human observer has a lot of limitations, biases. It is a human being who is basically seeing objects at predetermined or fixed distances. So when the observer reports a visibility of 3 kilometers or 4 kilometers, from the air traffic control or from a position in the airfield, there are predetermined objects which are measured at that distance. So if the observer can see that object, which means the visibility is what has been established. Now, the definition of this visibility has changed. Earlier it was the minimum, now it is the maximum distance at which the observer can see. So there is a lot of subjectivity to it and not very accurate. As the aircraft comes in, the pilot who is in the cockpit is seeing the runway at a slant distance. So you can imagine a triangle. So the pilot is basically looking down the hypotenuse of the triangle, the slant angle. Now this slant angle cuts through layers of the air and he sees the runway through a slant. So that is called a slant visibility. So this layer could be thinner than when he comes down to about 100 feet or 200 feet, or when he's very close to the runway. So as the pilot keeps coming down, this layer of visibility or air keeps on increasing. So a pilot may see the runway from about maybe 1,000 feet, but as the pilot comes down, the runway disappears because this layer keeps on thickening. So there are certain visual illusions also associated with it. So it is always important that the reported visibility is accurate, because that is what determines the operation of the flight. So if the reported visibility is, say, 800 meters, which is the minimum for a category 1 ILS approach, then when the pilot is at 800 meters, the pilot should see the runway. That is the minimum. So if it is very accurate, if an observer has reported, then there might be certain tolerances or biases. So maybe at 800, the pilot may not see the runway. So it is about the confidence the pilot has on the observation. So the more accurate the recording, so it is the pilot trusts the instrument or the observer. That determines the safety of the flight. Now, when it comes to instrument reporting, you have the automatic visual range assessment system. So there are different kinds of system, but as I'm told in Cochin, you have the Avara. So an automatic system it does not give a slant visibility, it gives a straight visibility through two instruments which are talking to each other. So that is a determination of what the pilot would see when the pilot sights the runway. So it is not a slant distance, it is a horizontal distance. So that is a more accurate depiction of what the pilot would see. And that is what a pilot wants, that when it is reported as 800 meters, I should see 800 meters. So that is the importance of having an accurate reading from a instrument reporting the runway visual range or the visibility. So this runway visual range now determines the safe operation of aircraft. In India, we have a number of airfields where human observers still report the visibility. But there are other means of converting this human observer visibility to a runway visual range, which means if it is night and there are lights like centerline lights or approach lights, the pilot is more likely to see the runway from a farther distance than during the day, because lights are more easily identifiable. So there are means of converting, but still we are converting human reported visibility into a kind of instrument reported. But if we have a system indigenously developed, but that can be put at every airfield, so there will be safety and reliability of operations. So ultimately, what do we want? That we want aircrafts to take off and land safely, and the operation should be efficient and reliable. So through this instrument, we can achieve the basics or the foundation of safety that is built on repeated, accurate, and more efficient systems. So that is what this instrument basically provides us. Now we have non-precision approach. So when a human observer reports visibility, the requirement increases. But when an instrument or a runway visual range is cited, the visibility required to operate to the airfield reduces because that is more accurate. So if these instruments are installed at all airports, then of course during periods of low visibility or poor visibility, there would be more reliability of operations and safety can be assured. So that is, so the visibility is basically the determining factor for safe operation of any flight.
Let us hear from a former Indian Air Force MiG-21 fighter pilot who is now a commercial pilot and simulator trainer and author, Captain Avinash Chikte.
Okay, to answer your question about Cat 3, firstly, the RVR is reported anytime there is a change in RVR. And the ATIS, Airport Terminal Information Service, continuously broadcasts the current RVR. And whenever there is a change, ATC informs us also. Because an accurate RVR is necessary for our decision whether we can land or not, depending on the minimums of the aircraft and the training of the pilots. Like I am Cat 3 Alpha qualified. Not everybody is. And now we have some Cat 3 Bravo aircraft also, but I'm not yet qualified on that. And the requirements for Cat 2, we need to see at least 3 lights, consecutive lights, and a lateral element. And for Cat 3 Alpha, at least 3 consecutive lights. It says a lot of things about central line lights or runway edge lights, but basically we are looking for the central line lights, and that's what we normally first see. And it is a very finely tuned, established procedure where everybody, the captain, the pilot, the co-pilot, the autopilot, everybody, and the auto throttle, of course, everybody is doing their job. And in case of something not working out, either the visibility dropping, the visual cues not being available, or any equipment failure, we go around. By go around, I mean you are coming into land, you decide we'll go around and come back for another attempt, or divert to another airfield where the visibility is better. So the procedures are clearly established. There is no room for doubt in that. We practice this every time we do a simulator, and everybody is clear about the procedures. And like we were discussing yesterday, that go round, which a lot of newspapers mistakenly call as a aborted landing, there's nothing dangerous in that. I mean, we do it very often. Anytime the landing is not working out, we are required to go around and make another successful attempt instead of landing off a unstabilized approach. And even go rounds we do practice a lot, especially in the simulator. So it's a well-rehearsed, well-practiced procedure. It is challenging, yes, it is demanding, but it's no way is it dangerous. Right? Does that?
The pilot while taking off also needs to be able to see up ahead the runway lights and markings. The estimation of RVR needs to be done in time to avoid danger of a crash and also fuel wastage due to the pilot needing to go around or abort or divert to another airport or runway. The air traffic controller of the airport needs to inform the pilot of the prevailing RVR. When RVR is estimated manually, There is a lot of variations depending on the eyesight of the person taking the readings from a distance of the runway lights, the point of reference used, the weather conditions, the glare and the surroundings. Whenever a decision needs to be made to permit a plane to land on Indian soil or take off into the Indian skies, there are a number of important factors that need to be considered. One factor of vital importance is accurately estimating the distance from which the runway lights and markings would be visible to the pilot. This is called runway visual range, RVR. The pilot needs to be able to visually see the lights and markings on the runway in order to descend and touch down at the right zone on the runway, at the right speed without overshooting the runway. If he brings the plane below a certain height, then due to the weight and speed of the aircraft he is committed to land the aircraft or to attempt a low-level go-around. This is a missed approach, which also needs to be factored in while fueling the aircraft prior to takeoff.
50, 40, 30, 20.
AVRA from the 1980s till today due to its automation makes a vast difference for pilots taking off from or landing at Indian civilian and military airports in both bad weather and fine weather. It is a vital decision-making aid in all weather conditions, prior to landing or takeoff by pilots and ATCs. It reduces the dangers of crashes and delays that were affecting passengers, cargo, airports congestion and causing unnecessary expensive aviation turbine fuel, ATF, consumption. A diversion in a flight can cost approximately around 5 lakhs INR to 15 lakhs INR. A delayed flight can cost around 2 lakhs INR to 4 lakhs INR and a cancelled flight can cost approximately around 6 lakhs INR to 33 lakhs INR. Costs associated with loss of human life due to a crash, on the other hand, are unfathomable to the families of those who lost their lives and the future of both the families and the country. Dr. J.P. Pichamuthu and his team, in order to reduce this, personally implemented the system on site at various airports in Delhi, Chennai, Madras, Bengaluru, Bangalore, Goa and other locations in India from the 1980s to 2000s. The essential core, transmissometer, of the indigenous automatic visual range assessor AVRA system continues to form the core of the rebranded instruments now being deployed at more Indian civilian and military airports. His son, Sunil, also contributed to the design of a graphical user interface for the AVRA and as part of his final year project work developed code for data collection and graphical user interface for the Automatic Weather Observation System, AWOS, built by Dr. Pichamuthu's team. Automatic Visual Range Assessor or AVRA is listed as part of the existing systems and features at Cochin International Airport, CIAL, in 2021. Several confirmed orders with the Indian Meteorological Department and Indian military were delivered through NAL, industry collaboration from 2003 onwards that drive Pichamuthu's team initiated with public and private firms. His team ensured quality standards were maintained while marketing, installation and maintenance were outsourced. This is helping NAL in the technology transfer and marketing of Automatic Visual Range Assessor Transmissometer under a different brand name in a growing and needy Indian market. Post-retirement work and activities. Dr. J.P. Pichamuthu, after his retirement from NAL in January 2005, was also the first Asian to receive the prestigious United Nations World Meteorological Organization (WMO) Vilhya Vaisala Award in 2006 for his post-retirement research work on generalization of the Koch-Mitter law of visibility. He continues to actively pursue research post-retirement. Dr. J.P. Pichamuthu, who was keen in inculcating the scientific temper in the future engineers of India, went on to become the professor and head of the Department of Electronics and Communication in Sir M. Visvesvaraya Institute of Technology, Bangalore. His teaching methodology and ability to spur his students to think deeper and work harder was appreciated by his students. His old students on his retirement from the college presented him with a bust of his that they commissioned. His keenness in stimulation of thinking in a scientific manner by Indian youth was also shown when he was the chief guest in 2006 at a science exhibition held at his son's old school St. Joseph's Boys High School, SJBHS, Museum Road, Bangalore. He ensured he visited all the exhibits and asked searching questions on the scientific principles of the exhibits to all the young exhibitors, making them to think deeper and about the basic concepts and principles governing the exhibits. This is a tribute from an Indian air passenger and son to his scientist father Dr. J.P. Pichamuthu and his indigenous invention, the automatic visual range assessor, or ever aiding aviation safety for generations to come.
Bye.